So, scientific notation. We are going to talk about converting scientific notation to standard form. Scientific notation, it's the mathematical expression used to write really large or small numbers. Remember, that's numbers. And it is always written between 1 and 10 multiplied by 10. So remember, and this is important, so the number has to be written between 1 and 10, and then it's always multiplied by 10. So if you look at that, this is the number written between 1 and 10. Oops, I gotta move it up just a little bit. And then it's always multiplied by 10. Always a 10. And then the 4 tells you how large or small the number is. And it's the exponent tells you. So your number is always going to be between 1 and 10, so it could be 8.3, it could be 1, it could be 1.456. But this number always has to be written between 1 and 10. It's always a multiply. Yes, we're using a x looking thing again, and then times 10 to the 4th. Or any number right there. That can be any number, and then this number has to be between 1 and 10. So I'm going to move this next part up. Remember, pause it until you get everything written. So notice it's scientific notation, expanded form, and then standard form. Now, here's a trick for you guys. On a couple of assignments, I have seen where students are getting stuck because they look at the negative first and they don't remember what to do. I honestly, if I see a whole list of numbers, I always start with the positives, and then I can always come back once I figure these out. So I'm going to start with these here, the positives, the zeros. So if I have 2.41 times 10 to the first, and I'm going to get a post-it to talk about a few things. So if I have 10 to the first, so 2.41 times 10 to the first, and don't write this in your notebook, these are just a side note. If we think about what we've been looking at, anything raised to the first power, that just means I have 110, so it would just be 2.41 times 10. Well, remember, when you multiply, you can do it in a calculator or you can do it by hand if you want, is 24.1. So equals 24.1. So remember the exponent rules that we've been talking about. This is just telling us it's 10 to the first power, which is just 10. And then if I multiply these two things out, I get 24.1. So now let's go ahead and write that. So it's 2.41 times 10, which is just 24.1. Okay, let's go to this next one. And this is purple. It's just hard to see that it's purple. Okay, now I have 2.41 times 10 squared. So 2.41 times 10 squared. Remember, if I have something squared, that means I have two of them, or 10 times 10. Well, 10 times 10 equals 100. So it's actually 2.41 times 100. So I'm going to write that here. So it's 2.41 times, and I'm going to put 10 squared, which is 10 times 10, which is 100. So 2.41 times 100. Okay? Times 100. So if I have 2.41 times 100, it's 241. Okay, this next one, 2.41 times 10 to the third, so 2.41 times 10 cubed, 10 times 10 times 10, 10 times 10 times 10. So 10 times 10 would be 100 times 10, or if I have 10 $100 bills, not a subtract. It's 1,000. So it's actually 2.41 times 1,000. So 2.41 times 1,000, which is 2,410. Okay, now let's go back up to the 0. So 2.41 times 10 to the 0. Well, we have 2.41 times 10 to the 0. Well, remember, anything to the 0 power is 1. So it'd be 2.41 times 1, which 2.41 times 1, sorry, my thing popped up saying my iPad was low. 2.41 times 1 would just be 2.41. Alright, now this is where it starts getting a little bit trickier. So if we have a negative exponent, so we have 2.41 times 10 to the negative first. Well, remember, I'll get rid of that post-it. So 2.41 times 10 to the negative first. Well, remember, what does a negative exponent do? It moves it to the denominator. So it would actually be 2.41 times 1 over 1/10. Well, you probably don't really remember what 1 divided by 10 is. It's just 0.1. So it would actually be 2.41 times 0.1. 2.41 times 0.1 is 0.241. So let's write some stuff in on your paper. So 2.41 times 10 to the negative first can be written as 2.41 times 1/10 because of that negative. Which is also 0.1. Sorry, that's little. Which gives us 0.241. Remember, use what we've been learning. The negative exponents, move that to the denominator. And then most of us don't like working with fractions. So if you type 1/10 into your calculator, you get 0.1. You can also type 10. Remember, we've been talking about the caret. So 10 caret negative 1, notice is just 0.1. So it's the same thing. 1/10 is the same thing as 10 to the negative first. Okay, let's do this last one, and then I want to show you a pattern that's happening. So 2.41 times 10 to the negative second. What does a negative exponent do? So if we have 10 to the negative second, we know that becomes 1 over 10 squared. So 2.41 times 10, 1 over 10 squared. Well, 1 divided by 10 squared is 0.01. Two 0.41 times 0.01 is 0.0241. Or remember, you can type it in times 10 to the negative 2. 0.01 is the same thing as 10 to the negative 2. Okay, now let's find the pattern. So if you look here, from 2.41 to this, notice, or no, let's start here actually, sorry. Let's start at 2.41 to 24.1. So if you look, the decimal is right here. Originally, it was between the 2 and the 4. So there was originally a decimal there, and then we moved it 1 this direction. Here, the decimal was in between the 2 and the 4, but now the decimal's at the end. Remember, if there's no decimal written, we know that it's at the end. It would be 241.00 if you were talking about money. So this is where it started, and then it moves 1, 2 times. So that's twice. Here, it started, and then again, it's at the end. So 1, 2, 3. This one, notice, started there and ended there. This one was here and moved once. This one started here. Notice they all start between the 2 and the 4. And then moves once, twice. So do you see the pattern? This exponent is 3. It moved 1, 2, 3 times. This exponent is 2. It moved 1, 2 times. This exponent is 1. It moved once. This exponent is 0, so it moved 0 times. This is negative 1, and it moved once. This one's negative 2, and it moved 1, 2 times. So the pattern, the exponent tells you how many times to move the decimal. Okay, let's do another example, and then you can start on your assignment, and then you can, that will be it for today. And then there is an assignment. So 3 times 10 to the negative third. We might actually do 2 examples just to make sure. So if I have 3, now you could expand it out just to make sure that you know what you're doing. Or if you can remember this pattern, that's how many times you're going to move the decimal. If the number is getting smaller, we know that this is a negative. So right now the decimal is right behind the 3 because there is no decimal written. I'm going to move it 3 times. 1, 2, 3. Fill it with zeros. So the answer here is 0.003. I can type in 3 times 10 caret negative 3, and it's going to give me 0.003. Let's do one with a positive number just to make sure. So now if I have 4.83 times 10 to the 6th, I need to move it 6 times. This is not a negative. I'm not multiplying by a fraction here. I would be multiplying by, let's see, 10 to the 6th, so 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I'd be multiplying by 1 million. So I can tell you right now it's going to be 4.8 million. But we'll go ahead and move the decimal. So let me change to blue. 1, 2, 3, 4, 5, 6. And that's kind of hard to see, but I'm going to fill each part right there with zeros. So it would be 4.8 not point, sorry. 4, let me get white out. Or you can just mark it out and do it right underneath it. So it'd be 4, 8, 3, and 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. That's a decimal, not another 0. So 3, 1, 2, 3, 4. So I filled with 1, 2, 3, 4 zeros. So 1, 2, 3. So again, it's 4.8 million. And so that is how you can convert from scientific to this. If you know that it's 10 to the 6th, or 10 times 10 times 10 times 10 times 10 times 10, you could count you can look at this and say that it's 1 million. So you know it would be 4.83 million or 4,830,000. This one, since it was a negative, you had to move it to the left or make it a smaller number.